Hello, and welcome to AP Daily for AP Physics C, Electricity and Magnetism. Today we're going to look at topic 9.2, electric potential. This is video 1, and we will be exploring the relationship between electric potential and electric potential energy. I am Michelle Strand. I am coming to you as an Einstein Fellow on Capitol Hill in Washington, D.C. So let's review. So remember, our equation for the electric potential energy was U sub E is equal to K Q1 Q2 divided by R. Electric potential describes the electric potential energy per unit charge. So we end up with V equals capital U sub E divided by Q. And when we do that, one of the charges cancels out and we end up with KQ over R is a way to find the potential, or V. You can think of it also this way, that the potential energy is the charge times the potential. And similar to electric potential energy, the electric potential is a scalar quantity. So you need to account for those negative charges as negative when calculating your total potential. So you can have a negative electric potential energy. You can also have a negative electric potential. So sometimes when we talk about summing them up, we say that V equals K, and then we have the sigma symbol for sum of the individual Q divided by R. So the charge divided by how far it is from where we want to know the potential, and we sum all those up. Again, making sure we plug in the negative if we have a negative charge. So let's take a look at an example. Here I want to derive an expression for the electric potential at point A. We are going to assume that this is a square, and so the sides here are all R. So I need to figure out what the electric potential is from at point A, from the positive Q charge and from this negative 2Q charge. So the potential is going to be, again, the sum. I'm going to have KQ over R for this positive Q charge. And then I'm going to have minus, because of the negative 2Q, 2KQ over R. And so if I have KQ over R minus 2KQ over R, I'm going to end up with minus KQ over R. And that is the expression for the electric potential here at point A. So now let's take a look at some practice. So here now I have some numbers. So at point A, again, I want to know the potential at point A is going to come from this positive 4 microcoulombs, from this positive 6 microcoulombs, and from this positive 10. I do need to know the distance between point A and this 6 microcoulomb charge. I've made this simple. This is a 6, 8, 10 triangle. And so now if I want to calculate the electric potential at point A, I can take out the K, which is 9 times 10 to the 9. And then I need to sum up the potential from each of these three charges. So it's going to be 4 times 10 to the minus 6 divided by how far it is away, which is 0.06, plus I'm going to have 6 times 10 to the minus 6, and that one is 10 centimeters away, so 0.1, plus I have 10 times 10 to the minus 6 divided by how far it is away, which is 0.08. So we do all those calculations and we come up with a potential that is 2.27 times 10 to the 6th volts. So again, it's just about adding them up. This particular case, I had all positive charges, so I'm going to end up with a positive potential. So here, how do we link it to potential energy? Remember that to change potential energy, I do work. And so this is asking us to calculate the work needed to move a charge of Q positive 2 microcoulombs from infinity to point A. At infinity, we assume that the electric potential energy is 0. And we assume that the potential is 0 out there as well. So remember that the change in the potential energy, the electric potential energy is equal to the work done, which is going to be Q times delta V. And so the Q is 2 times 10 to the negative 6. The delta V was what we calculated in that last example. So 2.27 10 to the 6th. The 10 to the 6th and 10 to the minus 6 cancel. So my delta U, or the work I need to do to move this charge, is going to be 4.54 joules, right? It's an energy change. So what should we take away from today? That the electric potential is a scalar quantity, and it can be negative or positive depending on the charge, and that we just add them up if we've got multiple charges, and that the electric potential energy is assumed to be 0 at infinity. Hope that was helpful. Thank you, and have a great rest of your day.